Hello and welcome to the lecture series on Principles of Electrical Engineering. In this lecture, we would try to solve this AC circuit, and try to find out the current flowing through this 1 ohm resistor by applying each of these theorems and methods: the nodal analysis, the superposition theorem, and then the source exchange method, and the Thevenin's theorem, and finally the Norton's theorem. So we would be applying these 5 ways of solving the same circuit and see what's the difference and which one is better. So let's start with the nodal analysis. Okay, so let me redraw the circuit once more here. So we have got, okay, so we have got a resistor, and there is an inductor, a current source here, 2 angle 0 degrees, and then a voltage source, and it is connected to this resistor through which we have to find out the current I0. It is also connected to a 1 ohm resistor and then a capacitor, and this is minus J. This is 1 ohms. This is also 1 ohm. This is J ohms, and this is 1 ohm. Okay, let's start. So we will try to solve this circuit with the help of nodal analysis. So let us try to apply KCL at this point. And let me assume that the voltage here is V1 and the voltage here is V2. And also let me assume that the current that is flowing here in this branch is I1 here, and a 2 ampere current is already flowing here. And let me assume that the current which is flowing here is I0. It is I0 actually. And let me assume that the current flowing here is I4, and the current that is flowing from here is I3. Okay. This is, let me rub it. This is I and 3. Okay, so let's apply KCL at this point, at the point V1. So we know that the current coming at this point, at this node V1, will be equal to the current going out of the node, or in other words, the sum total of all the currents that are coming at this node V1 would sum up to 0. So let's write down. So I1 minus 2 angle 0, and then plus I3 should equal to 0. We know that I3 is basically I0 plus I4. So this is equal to 0. So I1 is V1 upon 1 plus J. So this is voltage V1 here, and let me assume that this is at ground 0. So the current I1 that will be flowing is the voltage V1 divided by the impedance encountered by the current I1, so which is 1 plus j. So that's why I've written v1 by 1 plus j minus 2, an angle is 0 degrees, plus I naught. So I naught, I'm assuming that the voltage at this point is v1, sorry, v2. So it will be v2 divided by the impedance encountered by current I naught, which is 1 ohm, and finally I4 is again v2 divided by 1 minus j, which is the impedance encountered by I4, and this sum should be equal to 0. Okay, so one more thing, if I see here, if I try to apply KVL from point V1 to V2, then I can write, let me call this as equation 1. I can write V1 plus 6 angle 0 degrees is equal to V2. Fine. So you could see from here, so at this point V1, and there is a voltage, okay, I haven't written down the value of this voltage. Is basically 6 angle 0 degrees, this voltage, and then finally we have V2 here. So the voltage between V1 and V2 is 6 angle 0 degrees. Okay, so that's what I have written it here. So let me call it equation 2. So if I combine equation 1 and 2 and replace V1 by the expression of V2, so my equation 1 will become V2 minus 6 angle 0 degrees divided by 1 plus j minus 2 angle 0 degrees, and then plus V2 and plus V2 by 1 minus j, and this is equal to 0. Okay, so now we have only V2 in the expression. Let me take it outside. The terms that contain V2, I would be taking them on the left hand side and taking V2 common, and the remaining term on the right hand side. So this becomes 1 by 1 plus j plus 1 plus 1 by 1 minus j. So this 1 plus j basically comes from here. It comes from here, and this one basically comes from here, and this comes from here, and this is equal to 6 plus 2 plus 2j divided by 1 plus j. Okay, and finally if I try to solve it for V2, I will get V2 equals to 4 plus j divided by 1 plus j, and this much volts, and finally I naught will be equal to you see what is I naught. So just see here, I naught is the current that is flowing through 1 ohm resistor here. Okay, so and the voltage here is V2. Just see here, this is V2. So we can write down I naught in terms of V2 and the resistance 1 ohm. So that would be V2 divided by 1 ohm. So finally this is equal to 4 plus j divided by 1 plus j, and if I reduce it further, it would be finally be 5 plus 3j divided by 2, 5 minus 5 minus 3J divided by 2, this much amperes. So this is the current that would be flowing through the 1 ohm resistor, which we intend to find. So this is how we have found out the current using the nodal method of analyzing the circuit. Next, we will try to analyze the circuit with the help of the superposition theorem.